So as I mentioned just now, this subject, okay, I'm here to help you. Okay, so this is not something that you have to memorize things or memorize uh, formulas, okay? But this is to help you for your master dissertation. Master dissertation meaning that it's not similar to the one that master by research, where they have to write a full thesis. So think about if you are familiar with your final year project, okay? So it's sort of that kind of things, but then it's a bit more advanced, okay? But the thesis, the dissertation in the end that you will write, okay? So will be not that thick, will be a short one, okay? But however, since it is going to be a very time consuming, so that's why you have to really plan, yeah? When you are going to start your project, okay? So this research proposal, a research methodology class is to help you preparing, of course, the first one, research proposal, and then also train you on how to present the research proposal, the pitch, okay? And to guide you on how to conduct, which is the research design. How do you design the whole plan of your dissertation, okay? And lastly, of course, for you to write, okay? Because once you have proposed, you pitch your proposal, endorsed, and then you conduct the research. Lastly is to file, to do the reports or to write the dissertation. Okay, of course, you can read through the module, but during my class, it's more like a sharing session from me. Not to say I am, you know, an expert, but I do have experience. You can call around 25 years of doing research. So starting from my PhD until now, right? So before we start uh, talking about proposals, let's get to know different types of research. Okay, there are different types of research. So definitely, research is investigation, studying on solutions of problems that you have chosen. Okay, so we'll be talking about the problems, how to look at the problems later, but this is definitely one of the research definition. You have a problem that you're trying to solve, and you have the solution. Okay, problem first, solution, and definitely you the solution, it is based on your previous knowledge about the problem. Why? Because you cannot give solution if without knowing that actually someone has done that. So that's sort of useless, because if someone has done the same solution, so by right you should be improving. Okay, doesn't have to be totally new, but you need to do some modification in order to improve the weaknesses of the previous solution. That's why previous knowledge about the problem and the solution that has been carried out is very important. Mhm. Okay, general environment, yeah, something related to that. Okay, all right. So why do we do research? Of course, because you are studying, and uh, the structure of the study plan requires you to do 6 credits of uh, research or dissertation. Okay, but if you are working someday, or you are working now, you also have to do sometimes troubleshooting, okay, where you have problems at your working at your working place. You need to do some troubleshooting, okay? So some troubleshooting can be small scale, some troubleshooting can be large scale. So those are also research. Because in order to do troubleshooting, you cannot just do blindly, meaning that you test all the machines what available in your lab, for example, or in your factory. That is not something that you can do. Okay, you also have to start somewhere. So it is also a small scale research because you are trying to answer the problem or the questions. Okay. All right, so those are research. I'm not going to be very lengthy on this. Okay, benefit of research is a lot. As I said, it can be small scale, it can be large scale, depends on your situation. So in your case, it's more on academic, scientific contribution, okay, to humankind, of course, and some probably helping society, okay, helping to form policies, okay, to provide solution, right? Research can probably eventually lead to action as well, okay? All right, personal interest, okay, all right. Personal interest and bias must not affect the study. Uh, Personal interest is okay for me, but bias is, of course, not good, especially when you start doing measurement or data collection. Because once you have the bias inside you, then you tend to make up the data. Okay, you make some amendments, you make some, because you have this bias. So in science, it must be based on scientifically proven theories, established methods. That is what we call, that's why it is established, okay? Established methods in order for you to develop a new uh, solutions, okay? So this one we will discuss in detail in research design. So don't worry about this. But then the keywords here, bias, yeah? Okay, so in science, if you are biased, then the outcome of the measurements of the analysis is going to be not reliable. All right. Okay, this one I mentioned a bit. Depends on what kind of research you probably have your own interest. Okay, or you have to work under certain supervisor, and that supervisor has certain projects that he or she wish to complete, so you just answer to that. And also, most of the time, like me and the rest of the lecturers, we are answering the grant provider, the fund of the researcher. We cannot like beyond the scope, okay? Because we are answerable to the fund provider. Okay, so that's why you see some lecturers working on this, the other lecturers working on this. Why do they have to answer to do that specific? Of course, we do based on our expertise, but also to answer our fund provider. Okay, like also it can be the organization interest. Okay, for example, in because University Putra Malaysia is actually pertanian untuk rakyat, agriculture for the people. So you see that most of the research are related to agriculture, which is good because food security is very important. Okay, so quantitative or qualitative. So research can be quantitative, also qualitative, right? And of course, there are basic research. Basic means fundamental, like Hong Yan is doing something related to electrospinning, okay? So you're doing some basic research. But let's say after you finish your basic research and then it can be applied, right? It can be applied into, for example, making something like batteries or energy storage. And now you start to think about applied research. Okay, so usually these go in parallel. Okay, meaning that the basic research start, and then applied research also being carried out by the same researcher. Okay, the rest of it are just like actual exploratory is actually lower than fundamental. You're doing something that um out of uh I mean the knowledge about that particular scope is very limited, so that you just explore. Okay, so that is exploratory, but usually that happens if you have a lot of money. Meaning that you um invest on something that you don't know the outcome. You might have a good outcome, or you might have a negative outcome. So if we have a lot of money, we can just spend, explore. That is exploratory. So as I said, it is lower than the fundamental. Fundamental means that you have theories. You understood theories, you understood that the metal A or metal oxide B is behave like this. So you just, I mean, coordinate them, studying a new theory. But for exploratory, is somewhat new. Okay. Okay. So this one I have discussed. Okay. So when you do whatever that you do, all right, whether it's quantitative or qualitative, okay, there are certain types of research principles, certain principles of research, okay, that has to be in your mind, okay, when you do research, regardless of any research that you do, any different type. Okay, so if you are working with samples, okay, whether you are doing like surveys, whether you're doing like uh, development of or preparation of nanomaterials, okay, you have to think about representativeness, the samples. Okay, so when you do, for example, preparation of metal oxide, okay, and then you send to XRD, you send to any other uh, characterization, what we call as spectroscopic characterization or morphological characterization. Okay, this one we will discuss in research design. But how do you send the sample? How much sample or how much do you need to prepare? So whether you prepare it the same way, you have a same set of preparation, or you just prepare and then you send, and the next time you just prepare, and then the next, there is no standardization of the protocol or the procedure. So if there is no, then the principle, which is the representativeness of what you are doing, will be uh, not fulfilled. So in research, you have to think about whether the objective of your research has been established, but the action that you do does not represent what is the objective that you have proposed. So the best way is to understand representativeness is, let's say you are sending samples to FTIR, for example. So usually in Viva, okay, we usually ask how many times you prepare the sample, okay? So how do you control the reproducibility of preparations, okay? Because once you, if, how many samples that you send to FTIR for the same set of preparation, because if you say only one, then it's difficult to say about the representativeness, okay? All right, so validity. Validity is about the usage of established method. Okay, how do I say that? Okay, let's say you want to do metal analysis. Okay, so metal analysis, there are a few types of metal analysis machines or instruments that you can do. For example, AS, ICP. Okay, those are for metal ions analysis or metal analysis. So you have to choose the right method. Okay, for those of you who are working, I'm sure that you know all this. Okay, you need to have something that is valid. The word there is valid, established for that particular samples. All right, so you don't send to somewhere, or because it's not somewhere, you don't use wrong methods or wrong instrument to run for that particular samples. Okay, reliable. We will talk about reliability because it is related to whether you have replicates, okay? How do you operate your lab? How do you prepare for your samples? So are you reliable enough in your uh, working ethics? Replication also related to reliability. So definitely you cannot just prepare the sample once, or you cannot just have all the along your study, you only prepare once, then that is not really reliable, that is not really valid. Okay, objectivity is very important because once you have proposed, your objective is to achieve whatever that you have hypothesized, and you report based on your findings. Okay, so precision and measurement. Okay, so in statistic class, we have talked about precision, right? So precision is how close your data from each other. Okay, that is very important. And if it is haywire, if it is too far among each other, then you have to think about repeating the measurement. Okay, the most important here, okay, is ethics. Okay, you cannot have all this if you don't have ethics. Meaning that if you unethical as a if the researcher is unethical, then all these principles I think will not be uh, will not be applied to in the research. Okay, because if you think if the researchers just want to have okay, just run and get the data, so the validity, the reliability will not be there. Okay, as a scientist, we look, we think, and then if we have to repeat, we have to repeat. Okay, but again, that is the function of your supervisor. You need to discuss why is the reading weird? Why? Why do you think that I don't get data? So you have to talk to your supervisor. All right, so that refers to decision, okay, something validity. These are all the details that I have presented just now, okay? But again, the part that I really want to uh, point out here is the ethics, okay? Honesty, okay? Reporting data, okay? Honestly report data, results, methods, and procedures. Do not fabricate. Do not falsify, do not make up the data, do not deceive colleagues, okay, granting agencies, okay. These are all related to ethics. Objectivity, strive to avoid bias in experimental design, okay, data analysis, data interpretation, okay. So this one also related to ethics. Integrity, okay, everybody I think know about the word integrity. Uh, it is related to ethic as well, okay. Avoid careless errors and negligence. Okay, carefully, critically examine your own work. Okay, which is, I think I will talk about this a lot of time, that you have to, when you have data, look at it, and look at it. Question yourself, question the data before someone else question you. Okay, keep good records. Okay, this one is very important because things can happen. Probably your laptop or your what way that you keep your data is damaged or broken. So make sure whatever data that you have, you need to have backup. Okay, so if you're good in using cloud, probably you can store some in your cloud. All right. Openness. Okay. Sometimes there are some research is not to be open. Probably it is industry secret. Okay, so you have to be careful. This one you need to talk to your supervisor. If your supervisor insists not to disclose anything to anyone, then you have to be careful. But then, yeah, I mean, proposal is still a proposal. You will be evaluated by the panels, the examiners. You still have to talk about it. Okay, respect for IP. I don't know whether you know what is IP, but I will give you some ideas later. IP is rights, yeah? The rights of someone towards that results of the research. So it can be patents, it can be copyrights, it can be trade secret. Okay, so you need to have respect for them. So if it is not your right to disclose the data, so please don't plagiarize, don't copy and paste in your thesis without permission. Okay, right. This is very important. This is one of the ethic as a researcher. All right, confidentiality also. All right. Depends on the situation. Some works, like if it is in industry, there are, of course, it is related to profit, okay, marketing, their technology secret. So you need to keep your secret on the recipes or technologies. Okay, so this is confidential. That depends on the project. Responsible publication, we'll talk about it later. Respect for colleagues. Okay, this one if you are going to embark on research. Yeah? Social responsibility, non-discrimination in your research as well as in your publications. Yeah. What does it mean by discrimination is if you study the samples must be representative of the human being. Okay, so based on your research design. Competence, maintain and improve your own professional competence. Of course, if you don't know about the theory or the knowledge, you have to read a lot. Okay, not because of your ignorance or knowledge that you do it wrongly. Okay, so that's why you have to keep on reading, improving your skill, improving your knowledge. Legality, okay. So if you are doing something related to animal or probably clinical samples or whatnot, you need to have a proper ethic approval. Okay, so this depends on the country, depends on the regions, what types of ethic approval that you should apply before you do any of this research. So this is very important because there is one issue. If you heard about CRISPR baby, I don't know whether you know about CRISPR. Okay, CRISPR is gene editing tools. Okay, so there is one researcher. I don't know what happened to him, but I know that he has been prisoned. I don't know whether he's still in the prison or out of prison. Okay, he has done something on CRISPR baby. What does it mean? He modify genetically modify the gene of the baby, of the fetus. So you can think about what happened. Uh, CRISPR is very good for disease treatment, especially the genetic related disease. But then if you use it the wrong way or unethical way, then yeah, there is probably a repercussion, of course, for the researcher and the impact from that. So please take take note of that. All right. So I just want to show you, not to show you, but just giving you uh, the scenario. It's not really a scenario. It's a real story. Yeah, it's a real story about research in science. Okay, so this this lady named Elizabeth Holmes. Okay, some of you probably has heard about Elizabeth Holmes. You can search about this researcher, this scientist, or I don't know whether how to call it. She has come up with a technology called machines, yeah, called Theranos. So this is the face, and she's currently sentenced to be in prison. I don't know for how many years. Okay, for scientific fraud. Yeah. So that's why this story is very relevant to us when we choose to do related research. Okay, so what happened is usually when we want to diagnose disease, yeah, the blood that is extracted from us is called peripheral blood. Usually it is from here, whether you can see, okay, the normal way that you do blood testing. Okay, so she claimed that with her machine called Theranos, okay, only a drop of blood, meaning that a pinprick of blood, yeah, a pinprick of blood can be used to diagnose a lot of things like cancer, any other disease, you have diabetic or high blood pressure, whatever. So the story is Elizabeth Holmes dropped out of Stanford. Okay, this one well known, dropped out of Stanford because she's very ambitious and founded a company called Theranos, okay, with her tuition money. Actually, she actually obtained a lot of investors. She obtained and she convinced a lot of investors, even the president of the United States at that time. Now, instead of vials of blood, meaning that a lot of blood from peripheral blood, Theranos requires only a pinprick and a drop of blood. With that, they can perform hundreds of tests. Okay, so she is very convinced that her machines work. Okay, so Theranos is very big company, right? At the beginning, she got a lot of resources, investors. Okay, she even listed in those Forbes, Forbes under 30, I think. Okay, but of course there is what we call as whistleblower. The staff, I mean the research scientists who are working under this project is the one that blow the whistles. Okay, telling about there's a lot of uh, negative results and a lot of problems with that machine. So she, the whistleblower also is a she, cannot just be silenced and start telling about the story that Theranos is actually not working. Okay, so because of that, she was sentenced because of the uh, what we call as I don't know, is science fraud. Yeah. You can watch all these stories. They are also in Netflix, if I'm not mistaken, or is it in HBO? Okay, about this Elizabeth Holmes. So it's a famous story that happens in US. All right. So this is something, if you relate with ethic just now, okay, because of the bias and also probably personal interest that she really, really wanted the Theranos to work, that she just ignore all those unsuccessful clinical trials or validation process. Okay, so this is what happened to us if we ignore all this. Okay, in the end, the whatever that we propose, whatever that we report is not actually true. Okay, all right. So now is okay. It's almost 7. So I'm not going to discuss this. This is showing the signs is happening. Okay. So all right. So as usual, okay. So for those, I think some of you, I think the only one that don't know my style is Aisha. Okay, so my style of giving lectures is we start at 6. Okay, we start at 6 and end close to 7. During the first hour of lecture, I know that some of you probably still uh, driving or from somewhere else. So the first hour usually is by me. A lot of discussion will be initiated by me. And we from 7 to 8, you can have a rest. Okay. And probably during the 7 and 8, I give you some activities or some to reflect whatever that we have discussed just now, or some documents to read. Okay, so 7 to 8, you do that, and then we come back using the same link to continue from 8 to 9. Okay, so for the 7 to 8, okay, I hope that you can just watch the Elizabeth issues, yeah, the Elizabeth Holmes issue. This is very interesting because if you watch the documentary or you read the stories, you really need to watch the documentary, then you understand the not to say the bias, the ambition. Okay, so I do have some respects for her because of her ambition. Okay, she actually, because she in Stanford, one of the prestigious university, but a dropout, of course. Well, Mark Zuckerberg also is a dropout. Yeah. So she actually went to see her professor and talked to her professor about her project. I keep talking about her project. Her professor said it's not doable. There's a lot of issues. Okay, so this Elizabeth just did not listen to her professor. So it's okay, but if you listen to her talking, okay, you will see that she tried to mimic Steve Jobs. If you watch the documentary, then you understand what I'm talking about. She dressed like Steve Jobs. She tried to talk like a Steve Jobs. Okay, she changed her voice to mimic Steve Jobs. Okay, so if you see the documentary, you understand. So in a way that she's very hardworking, very ambitious, but unfortunately, if we forgot about the ethic as a scientist, as a researcher, then it's not going to work. In the end, it's not going to work. Okay, so everybody, see you at 8. Use the same link. Bye. All right. Okay, so these are the basic structures of research proposal. We'll discuss what is executive summary. I'm sure that you know literature review because just now I have given you some like why you need to understand the problem in a correct point of view without reading, without talking to the right people. You cannot understand the problem well, and therefore your solution might be wrong. Okay, so you need to read a lot, yeah, for a full scale research uh, problems, uh, research project. You need to read a lot. Reading is the key, and talking to people, presenting, talking, asking to the right people. And definitely, very important in research proposal is to write a good problem statement, because if that's not correct, then you will have wrong objective. And when you have wrong objective, you will secure, you will have wrong research design and end up with wrong data. Because whenever that you don't understand the problem, you create the objective based on the wrong understanding of the problem, and from the objective you carry out design experiment which is not correct, and finally the conclusion that you wish to have does not answer the actual issue. Okay, so that's why you think that it is just some words that you just put it there, especially now you have chat GPT. You just put it whatever on a piece of paper, but understanding whatever that you have written is very important. Okay, so the first part, what we're going to discuss is the statement of problem. Okay, experimental design, Gantt chart is related, and we will talk about it in the next lecture. Okay, so title, as I said, is not really important for me at this stage because you can just always change the title throughout your research. Okay, only when you need to present, you need to have at least a reasonable title. Okay, so the title should be not too general, not too specific. For example, if it is general, meaning that, let's say, preparation of metal oxide nanoparticle, then that is too general. Okay, let's say you prepare 10 metal oxides nanoparticles. Well, you cannot put all the 10 in the title. You have to generalize some types of metal oxide nanoparticle. So that's a skill that you have to learn throughout the study. Okay, so this one I'm just giving some examples. When you write title, whether you want to use the word preparation, synthesis, or development, or study on. Usually the word study on is not really encouraged to use because you must specify whether you are preparing, whether you are synthesizing, whether you are developing. Okay, that is more representative of your research. Okay, so in this case, is development and microarray. The keywords are microarray for detection of metal ions. And the one that you want to use in this case is amino acid and peptides. Okay, so the title must be representative of what you want to do. Okay, definitely background. Just now I have tried my best to convince you that information, knowledge on background is very important. Okay, if not, then you will not be able to uh, do the lab and really answer some objective. I mean, if you just do, it will be like remember your practical during your bachelor. It's just that you do by looking at the manual. So that is what you will do if you don't sufficiently study the background. Okay, so you just carry out whatever in the manual, and in the end you get the data. But doing research is not that. Okay, when you read, you will be like asking questions. Why is this? What can we do to get better? Okay, so from there you create some solution, and then objective followed by design of experiment. Okay, right. This one I don't want to go through because introduction is like telling us the story of the problem, but not to say superficial, but it's enough for people to understand. That's why it is there in your proposal. Let's leave the executive summary behind. I will talk about this later. Okay, very important. If you intend to write for grant research proposal. Okay, so from the introduction, we move on to literature review. So again, literature review is a process for you to understand deeper on the problem. Okay, let's ask question like, where did the problem come from? Probably where, or what is already known. Okay, you probably heard about gap. Okay, the gap of this problem, the gap of this research gap. Okay, what other methods have been tried to solve it? So keep asking yourself about all this, but probably this question not suitable for you. You ask other questions, probably how, probably why, rather than where, what, and what. Okay, why, how, Okay, there's a lot of questions that you can ask. Okay, and you seek the answer by reading, by talking to people. After that, you can write a proper problem statement. Okay, so in problem statement, there are a few important things. Okay, of course, you know why. Right now, after doing a lot of readings, a lot of talkings, a lot of discussion, you finally know why the study was undertaken. Why meaning that importance. Why is it important to be research? Okay, and novelty. Novelty meaning that uh, there are different level of novelty. When we're talking about masters, especially in your case, dissertation, we do not expect a very novel work. Okay, so enough if you do some modifications, some additional material that is probably working. Okay, so it's a training. Yeah, it's a training for small scale research. But let's say you intend to do PhD, okay, later after you finish your master, and then you have to think about novelty. What does it mean? Is you're trying to do not something totally new, but at least is modified or is a new addition because you know that will improve the previous solution that has been carried out by some other people. So that is also considered novelty. There are some, well, if you're doing like PhD in somewhere in MIT, Harvard, or Oxford, and then you do your research with unlimited budget, then probably you can have something very new, probably. So writing statement of problem, these things has to be in your mind. So what is the problem? What do you want to solve it? How are you going to solve it? What is wrong with the current or previous solution? Okay. And the last one, what is the problem? Why or what is wrong with the current previous solution requires you to write some review. Okay. So I will show you some examples later. This tonight just giving you some ideas, okay? Okay, this is example of problem statement. Okay, try to note the things that I have mentioned just now. Okay, sorry. A statement of the goal of research, why the study was undertaken, the importance, the novelty, and the rest. Okay, let's look at whether this is inside the statement that I should. Okay. So the development of practical sensors, okay, so the goal of this research is to develop a practical sensors to detect and quantify metal ions in environmental samples. Okay, so that is something that an introduction for what is the objective of this research. Okay, so what's the problem? I mean, I'm sure that there are a lot of sensors that has been developed to quantify metal ions. So what's the problem? Okay, so come to the justification. Little research has been conducted based on peptide ligands. Okay, so now there's a new things that has not been researched a lot yet, which is peptide ligands. Okay, so so I okay. So I'm just showing that actually there's a extended uh this is not enough, okay? So we need to like further talk about this. Why peptide ligands? Even though it is not being researched well, probably it's not good. That's why. So you need to go give some evidence of research findings, the characteristic of peptide ligands. It has more binding toward metal ions, give some values, give some figures. So those are the things that convince people that yes, the problem is important and your solution is scientifically sound. Okay, So these two sentences definitely not enough. Actually, it's longer. But just to show you that these are something that needs to be in the problem statement. Okay, I hope that really uh, give you some ideas. Okay, let's look at this another problem. Okay, all right. So the issue of mercury. Okay, why do we concern about mercury? Okay, so based on the statistic, okay, this is something that you can put in your problem statement. EPA estimates that 300,000 newborn each year increase risk of learning disability associated with utero exposure to methyl mercury. Okay. So based on the actual report, EPA is environmental, I don't remember, agencies, environmental, is every year the newborn uh, has an increased risk towards methyl mercury. So you start thinking about, is this an important problem? Do we need to solve it? Okay. So, well, according to this, probably it's very important and we need to solve this. But looking at this map, so if according to the colors, the darker the colors means that the issues are greater. Okay, so we look at the map, then we start thinking, why do we have these issues in this darker colors part? Okay, what is actually contributing to the why is it uterus, yeah, exposure to methyl mercury is getting serious? Where does it come from? Okay, why do you think? Where does it come from? Hong Yan, where do you think come from? Where do you think the methyl mercury comes from?
Mm, do you think maybe chemical waste from the I mean just put it in the water or we put in the area or just something else to do?
Yeah, probably you're right, because we might think, okay,
Mhm.
probably the water, probably in the air, it's not
Yeah.
clean. Okay, so in order to answer that question, you have to understand what is methyl mercury, right? So methyl mercury is actually mercury, inorganic mercury being biodegrade by bacteria. That's how it becomes methyl mercury. Mercury, when is in inorganic, non-organic, inorganic form, is not volatile. Okay, but when it is biodegrade by a bacteria, it becomes what we call as organic mercury, which is methyl mercury. So when it is volatile, it is exposed to human. You can think about it's going inside your body, and but there are other words that make me think why it is uterus, why it is related to learning disabilities. Okay, so these are things that you need to ask more, need to study more. Okay, but I know a bit of the answer. Okay, so the issue here is more on the my view of this is on the use of uh, uh, petroleum. Okay, so uh, some areas are heavily contaminated with methyl mercury. So the other one is there a possibility that the mother is using a mercury contaminated cosmetics? Okay, because we see that it's a utero exposure. So those informations cannot just be like at your fingertips, but you have to read about it. Okay, so let's stop there. So what's the solution? Okay. Right. The solution probably comes from, okay, in this issue, let me close this first. see, just a moment. Okay, so because we use a lot of petroleum uh, related products, not just for petrol, not just for gas, but other things as well. And we can see that the mercury concentration in different parts of the world, you can see that numbers are higher. Okay, here, all right, Africa, you can see. So these are reported data. Okay, now we can relate probably the darker, wait, the darker parts, okay? Now we know that some data is on mercury, right? So what needs to be done once we know this issue? Okay, if it is related to hydrocarbon, isn't there any already solution to that? Is there any cleaning up that has been done to remove all the mercury in the petroleum products? It should be there, right? Okay, so what is seems to be the problem? So when I studied, okay, some of the commercialized solvents are not able to remove contaminants rapidly. Well, it takes time. Okay, difficult to regenerate is not related to, is more related to cost. Okay, some are not applicable for non-aqueous system. Some has leaching problems. So probably these are the issues that contribute to the mercury has not been solved. Okay, so yeah, and then you can continue talking about this. All right, so these are processes that you keep asking yourself, what is the issue? Why this happened? What has been done to solve this? So what can be done to improve this? Okay, so I think I hoped that I have answered, or sorry, I have discussed, and I able to make you understand about the statement of problem and the work that you have to do to make sure that you write a good problem statement by a lot of readings, by reviewing a lot of reports, and talking to the right people. So uh, that is the purpose of today's lecture, is just to make you understand that understanding the problem, to know the problem, reading a lot is the first process of doing research. Okay, so it's not easy, but reading is a must. Okay, all right. So I think that will be for today. Okay, so you can just have a look at my slides. Okay, this is about TB. Okay, what's wrong with the TB today? So actually today this is my third day joining what we call Global TB Summit. Yeah, a lot of clinicians, physicians talking about the issue of TB, the never-ending issue of tuberculosis, and recent reports from the WHO on the TB issues. Okay, so what more that we can do? Just now, Mariam talked about test. Yes, is the test reliable? Is the test cheap enough for everybody to use? And what about vaccine? Yes, TB already have a vaccine, but unfortunately, it's still a big problem. Okay, so right, any questions? I talk a lot. Okay,
Prof,
yeah.
I have one question.
Mm.
Let's say if we plan to do some method development, for example, and then we search information or material from the internet, and then how then we want to claim that our work is novel or something like that. But when we search in the internet, the some of the material is restricted. I mean, we have to purchase or we have to subscribe. but based on the headline, we can see their work is almost the same as what we want to do.
So
How to deal with this problem?
meaning is that if I'm correct, that you are trying to know the detail, but it is restricted. Okay.
Correct.
Based on the title, it seems similar. Okay. Right.
Yeah.
So that depends because, as I said, right now in your case, you are practicing. I mean, you are under practice to do the research. But in actual research, if you have that scenario, okay, what I do and what most of my friends do is we contact our counterparts. Do you have access to this? Do you have access to this? That's why you need to have networking with people because, yeah, we are restricted to resources. Okay. If it is uh, industry related secret, I don't think so they publish, right? But it is published, but it's just that we don't subscribe or we don't have access to that journal or whatsoever. So what we researchers do, we do network. So sometimes we know researchers in Germany. Sometimes we know researchers in UK. So sometimes they have more access than us. Okay, for example, recently there's one paper from Nature that I don't have access. UPM doesn't have access. But I know somebody in Germany who have access. So when you have friends and when you talk to people, you can just like send message through Facebook. Do you have this? Can you supply me? Okay, so that's things that you can do. So in short, you cannot give reason or excuse that you don't have access. So therefore, you cannot evaluate whether yours is novel or not. Okay, but as I said again, this for your short project is a practice. Okay, we don't really look or be very strict on your novelty, but in real situation, you must try as hard as you can to access the paper. Okay, is that okay?
Okay, Prof. Understood.
Okay, so make networks. Okay, any other questions? Okay, so right, thank you for joining me. I hope that the first stage, which is the problem, is clear to you. Okay, so next lecture, we are going to discuss probably objective, okay, because once we understood the problem, read a lot of literature, now we have some ideas about the solution. Basic ideas. But how do we carry out? We need to draft objective because in order to prove that our solution is working, we need to do some experiment. Okay, and that experiment should fall under certain objective. Okay, everybody, have a good rest. Your
Thank you
first
so
day,
much, Professor.
Doctor, have a
Thank
good
you,
night.
Prof.
You,
your,
Prof.
Thank you very much.
your first
Bye.
week must be very
Thank you.
tiring.
Thank you, Prof.
Okay.
Thank you, Prof.
Thank you, Doctor.